We'll continue on to the second part of lesson 6 as we're working through the rational root theorem, and then this half of the lesson we're actually going to kind of be working backwards. We'll have the roots, and then we'll be working to figure out what the function was to begin with. We have a couple of things that we need to review beforehand, and let's just start with this. Let's start with knowing we have a factored form. Let's say we have x plus 5 and we have x minus 3. And we want to know what the zeros are. So zero product property leads us to x equals negative 5, x equals positive 3. Now we've done a lot of that, so hopefully that is not a sticking point for you. And these are our roots. Now, what if we went the other direction? So we started with the parenthesis format, the factored format, and then we solved it. What if we went the other direction? So what if I asked you to start with the roots? So let's say we knew that x was equal to negative 7 and x was equal to 4. What would it have been like in the parentheses prior to that? Well, to get there, we would do x minus whatever that root is. So x minus a negative 7, which would take us to x plus 7. And then we would have x minus, and then you bring the 4 back across. So x minus 7, x minus 4. And then if we want to know what the function is, we would now multiply that together, or FOIL it. In this case, because we have two binomials, which you've heard me say before, that FOIL is nothing more than just an organized fashion for the distributive property. So if we multiply that together, x times x is x squared. 7 times x is 7x. X times negative 4 is negative 4x. And 7 times negative 4 is negative 28. And we've got some like terms that we can combine in there. And that will give us x squared plus 3x minus 28. So this quadratic, if we were to factor it back out, we would get roots of negative 7 and 4. We could do the quadratic formula. We could graph it. All of those things would give us the same roots. Another skill that I want to review with you before we get into this, because we're going to need to use all of these ideas, perhaps on a more complicated level, is difference of squares. So difference of squares. Remember, this is one of our identities where we can factor a little faster. So if I started with x plus 5, x minus 5, so you have the same first term, the same second term, but you have opposite signs. When you multiply this together, you're going to have x squared, so you take your first term and square it, plus 5x minus 5x, and then you're subtracting the second term squared, which in our case turns out to be 25. So these first terms, or excuse me, these middle terms right here, they're always going to drop out. That's what makes difference of squares its unique self. So when you can recognize difference of squares, notice that my first terms are the same. The second terms are the same, but I have opposite signs. One group is going to have a plus sign, the other group is going to have a minus sign. This means that we should be able to square the first term and then subtract the square of the second term. So again, x squared minus 25. So we're going to use all three of these ideas as we get into our notes. Please know my goal here is not to drag this out. I want to be thorough. I want to try to give you all the tips and tricks and all the background information that you need to be successful. We're going to look at something called the conjugate root theorem. And honestly, it's nothing new. We're just kind of revisiting it. I'm going to scroll back to lesson 3.5, the beginning of our notes there, where we had the image of the two blue people together there. So you have the a plus bi and the a minus bi. Remember, these are complex conjugates, so they always come in pairs, and that's what we're going to be dealing with in this part. So for this, if you have a plus bi, you're automatically going to have a minus the square root of b in this case. That one was a plus the square root of b, so we'll also have a minus the square root of b. And then in our second group right here, if you have a plus bi, then you'll automatically have a minus bi. Okay. I've posted on here or made a little comment, and I really hope that you'll consider it. All of these videos are on Canvas. And if you're stuck, or this seems to go too fast, or you need a refresher, or something along those lines, please take the time to go back and rewatch at your own pace, stop it, back it up, watch it again. There's an extra video on Canvas under today's date, February 9 and 10, so yesterday and today. It's called Edpuzzle A2 Notes 3.6 Example 4 Alternate Method. It's an approach Mrs. Verbenik likes to use when she's multiplying these all together. I take a different approach, so it might be good to see both sides of things, and you might find that you like that approach better. So please know that that is there for you. It is not mandatory. It is strictly optional. Okay, example 4. They want to know what is the function. That's what we're looking for. And we need degree 4. If we've got degree 4, that means we have 4 roots. So we know we have the root 2 minus the square root of 3. That means we automatically have 2 plus the square root of 3. And we also have 5i, which means we automatically have negative 5i. So there's your 4 different roots. Now, to get started, we are going to subtract the different roots that you are using, just like we did up above, up here. So we're going to start by taking x and subtracting one of those roots. So I'm going to do 2 minus the square root of 3. And then I'm going to do it with the other one, x minus 2 plus the square root of 3. Now, I know it starts to look like I have all these parentheses, I have all these numbers, it's all running together. I get that. I need you to just really try to focus and stay with it. You can do this. We also have x minus 5i, that's an additional root, and x minus a negative 5i. We're going to do some simplifying here. Our next step is to distribute those negative signs. Distribute the negatives. So we'll have x minus 2 plus the square root of 3, and x minus 2 minus the square root of 3. We'll have x minus 5i and x plus 5i. Now, the entire purpose and point of me coming up here, one of the warm-up pieces that I had you do was work through the difference of squares. That's what I'm creating as I'm rewriting these. So within my first group of parentheses, I'm going to group together x minus 2. That's the commutative property that allows us to do that. And then when you notice, I hope you'll notice that I have my first term is the same in both of them, and also the second term is the same in both. And lastly, notice that I have a positive sign, whoops, and a negative sign. So this is actually difference of squares. I think it's easier to recognize it in our second group. You have the first terms being the same, your second terms are the same, but you have opposite signs. Now, if you are still at the point where you need to actually FOIL all of that together and then cross out your terms, you are more than welcome to do that. But I'm hopeful that you'll recognize the difference of squares patterns here. So I'm going to go back to my intro, my review at the top, and I'm going to rewrite it as the quantities and squaring them. So I'm going to take x minus 2, because that's my first quantity, and I'm going to square it. And then I'm going to have minus my second term, and I'm going to square that. And I'll do that also with the x minus 5i and x plus 5i. So we have the first group squared minus our second term squared. And we'll begin to multiply this all together. The x minus 2 quantity squared, that means you're doing x minus 2 times x minus 2. That's x squared minus 4x plus 4. Then you'll be subtracting the square root of 3 squared. Well, the square root of 3 times the square root of 3 is going to be the square root of 9, which is 3. So when you square a radical, you get the radicand. This is going to leave us with x squared minus 4x plus 1. So the two roots that were 2 minus the square root of 3 and 2 plus the square root of 3, they're going to give us this quadratic, x squared minus 4x plus 1. If we did the quadratic formula on that, we would get right back to the beginning with these two roots. Let's go ahead and finish off the second side of this. X squared minus 25i squared. Maybe some of you are starting to recognize this I squared in here. This is going to give us x squared minus 25 times negative 1, which is going to give us x squared plus 25. And here is our second piece. And now we're going to take both of these and we're going to multiply. Once we have those all multiplied together, we will have our final result. We'll have the polynomial that we would have started with. So I'm going to organize my distributive property. I'm going to take a term out of my binomial, x squared, and I'm going to multiply it times the trinomial. And I'm going to take the other term out of the binomial, the 25, and I'll multiply by the trinomial. So many things that we've been using in previous lessons still tie in together here. X squared times x squared is x to the 4th. X squared times negative 4x is negative 4x to the 3rd. And x squared times 1 is a positive x squared. As I work on the next row of this, I'll shift everything so my like terms line up. And I'm going to have 25 times x squared, which is 25x squared, minus 25 times negative 4. That's going to be negative 100x, and then I'll have a plus 25. And we'll add all those together. You'll have x to the 4th minus 4x to the 3rd plus 26x squared minus 100x plus 25. So the question wanted a 4th degree polynomial. You'll notice that our exponent is indeed 4. That's what that means. And we have found the original polynomial. If we were to graph this or factor this or whatever, we'd be able to see real or no real roots. I'm sorry, we'd have 2 irrational roots, and then we would have 2 imaginary roots out of that. Watch this again. You'll be surprised at what the repetition will help you with. It's very important that you stay focused when you're watching them. You follow along. You try to connect with what's being written there and how those numbers come together. Every single one of you can do this, so give it a try. Don't give up. Keep chugging away at it. Get in and ask some questions. You can do this.